As I mentioned in the last video, what we are going to do now is solve various application problems. So we will read through each situation, draw it out, and then determine whether the law of sines or the law of cosines needs to be used, and then solve the problem. Okay, again, I'm covering both of these sections at the same time so you can understand the difference between the law of sines and law of cosines, when to use them, and how to use them. Then we will proceed after the application problems to look at the ambiguous case, which is side-side angle, and then we will end this section with a review of area. Okay, so let's get started on example 1. It says a pilot flies her plane on a bearing of 35 degrees in 0 minutes from point X to point Y, which is 400 miles from point X. Then she turns and flies on a bearing of 145 degrees in 0 minutes to point Z, which is 400 miles from her starting point X. What is the bearing of Z from X, and what is the distance from Y to Z? All right, read this problem thoroughly. Read it again and again until you understand what is going on. Okay, we're going to draw it out and then solve it. Okay, so this involves 3 different points, X, Y, and Z. Okay, and we have a couple of angles involved, and something you should notice about both the angles, they involve 0 minutes. So since we have 35 degrees in 0 minutes and then 145 degrees in 0 minutes, we can just treat them as both degree measures. We don't have to take the minutes into account because there are 0 minutes. So 35 degrees in 0 minutes, you can just treat it as 35 degrees. 145 degrees in 0 minutes, you can just treat it as 145 degrees. You don't have to worry about the minutes. Okay, so let's draw out the first statement. You have this pilot who is flying her plane on a bearing of 35 degrees from point X to point Y, which is 400 miles from point X. All right, so this first statement is involving the points X and Y only. Okay, Z will come along later. Okay, so let's start with X. Okay, this pilot is starting at point X. Okay, so I'm going to put that down right here. Okay, so here's point X. And she's flying to point Y on a bearing of 35 degrees. Okay, so we need to draw in the bearing. Okay, since this is a single angle for the bearing, we don't have any degrees. We need to put a little cross on X here to represent north, south, west, and east. Okay, so let me do that. And since it is a single angle with no direction, the angle is going to be relative to due north. Okay, so I'm going to make sure that the north side is a little longer here. Okay, so here we go. All right, this blue cross is representing north, south, west, and east. Okay, so now I can draw in the bearing. Okay, so here's point X. Imagine this black line segment is the flight path from X to Y. Okay, so to get the bearing, we're going to align ourselves with due north, and by definition, we're going to rotate clockwise by 35 degrees. Okay, so we're going in this direction, okay, by 35 degrees. Okay, and so wherever she ends up, that is going to be point Y. Now remember, the length of this line segment is going to be the distance from point X to point Y. And we're told that that's 400 miles. Okay, so we're not drawing this to scale. This is just a rough sketch, so we're going to drop it somewhere. This will be point Y. We know that this angle from due north to this line segment is 35 degrees, and we also know that the length of this line segment is 400 miles. Okay, that is what we got out of the first statement, and now we need to go on to the second statement. Okay, it says, then she turns. So at point Y, she ends up at point Y. She is going to turn there and fly on a bearing of 145 degrees to point Z. Point Z is 400 miles from her starting point X. Okay, so we need to draw that in. Okay, at Y, she's turning. Okay, and she's flying on a different bearing. So since the turn is occurring at Y, we need to put a cross on Y. So we can draw in the bearing there. Okay, So again, this is just a single angle that is being given. Okay, the bearing will be relative to due north. So I've got north, south, west, and east again. Okay, and then here comes my line segment. I will align it with due north. Okay, and I'm going to draw in the bearing here. I need to rotate clockwise 145 degrees. All right, so if I come here, this is going to be 90 degrees. And now if I keep rotating to due south, that's going to be 180 degrees. So I'm going to end up somewhere in between, due east and due south. Okay, so again, you're just kind of eyeballing this. So you're trying to draw in an angle of 145 degrees. Okay, so maybe about there. As far as the distance is concerned, like how long you should make this line segment, remember, we don't know the distance between Y and Z. That's actually what we're trying to find. But we do know the distance from X to Z is going to be 400 miles as well. Okay, so again, you're just trying to draw this as best as you can. Okay, I will drop it here. Okay, so this is going to be point Z. Okay, we know that if we rotate it from due north to this line segment, this is going to be 145 degrees. Okay, what we also know from this second statement is that if you look at the distance from point X to point Z, okay, it should be the same as the distance from X to Y. This is also going to be 400 miles. Okay, so that's what the picture looks like. And remember, if you read the last statement here, we're trying to figure out the distance from Y to Z. Okay, so we're interested in what this length is. Okay, we know the other two lengths from X to Y, from X to Z, both are 400 miles. Okay, so you may want to read through the question again and make sure you've got everything in the picture, okay, that has been described. Okay, and now we can start working on the answer. Okay, there are actually two things we need to calculate. Like I said, we have to find the distance between Y and Z. The other thing we need to figure out is the bearing of Z from X. All right, I am going to calculate the distance between Y and Z first, and then I'll come back and deal with the bearing. Okay, so that's my plan. Okay. So we are going to concentrate on this triangle that has been formed. Okay, if you notice, there has definitely been a triangle formed. Okay, I'm going to shade it in blue so to make sure you can see it. Okay, so here's our triangle. Okay, and we're looking for that yellow side of the triangle. We know the other two lengths. Okay, so again, you cannot assume that there is a right angle involved. Okay, you would have to prove that there is a right angle involved. Okay, so we need to figure out basically what the angles are that we do see in the picture. Okay, as far as our triangle is concerned, like I said, we know two of the lengths. We don't know the third side. We don't really know any of the interior angles of the triangle, so we need to work on that. Okay, so let's get started. When I look at this, this is how I view it. Okay, you can use these coordinate systems to create some right triangles to help you figure out various angles. So for example, if I look at this north, south, west, east coordinate system that I have on point Y, okay, what I can do is extend the east-west line right here. Okay, so let me kind of lift it up a little bit. Okay, so like this. Okay, and what happens here, it creates this right angle. Okay, because this is obviously a right angle because you have like two coordinate systems kind of coming together perpendicular at a perpendicular point. Okay, so that creates this right angle, and it creates this other triangle. Okay, so let me shade in this other triangle. Let me use a lighter color. Okay, so here's this other, hang on a second. Here's this other triangle that has been formed. It's a right triangle. So this guy. Okay. So we actually know two of the angles inside of this triangle. There's a 90-degree angle, and then we have the 35-degree angle marked. And so that is going to allow us to calculate the third angle inside the triangle. I can figure out this guy right here. So I know there's 180 degrees inside of a triangle. Okay, so then I need to take out the right angle. Okay, that's going to be 90 degrees. That's going to leave me with 90 degrees. then take out the 35-degree angle, and that's going to leave me with 55 degrees. Okay, so you can check that. 90 minus 35, that's going to leave us with 55 degrees. That is going to be the value of this angle right here. Okay, so what I'm trying to do, I'm trying to use these other angles like this. This is not an angle inside the blue triangle, but I'm trying to use these type of ancillary angles to figure out the interior angles of the blue triangle. Okay, that's what I'm trying to do. Okay, so I could do the same kind of thing over here. Okay, if I keep extending this line, okay, a little bit, remember, if I'm using this coordinate system that is in place on point Y, okay, north, south, and east, west, they intersect at right angles. Okay, so these are all right here at point Y. These are 4 right angles that come together. Okay, so I'm going to look at this bearing of 145 degrees. Okay, so that is comprised basically of 2 angles. I've got this right angle that I just drew in right here. Okay, this right angle, and then we go a little bit more to get the 145 degrees. So I'm going to be able to calculate this angle right here. Okay, if I go from due north over to this yellow line segment, I've rotated 145 degrees. Okay, but I know part of that is a right angle. Okay, the parts between north and east. Okay, so if I do 145 degrees and I take away 90 degrees, okay, that is going to leave me with what? That's going to leave me with another 55 degrees. Okay, so this is also a 55-degree angle. Okay, so then if I look at the straight angle, okay, meaning the straight angle formed by the east-west line on point Y. Okay, and point Y has kind of disappeared on me, so let me rewrite it. Okay, that straight angle should equal 180 degrees. Okay, so if I take out the 180, if I take 180 degrees, which is the straight line, it's the east-west line through point Y. Okay, if I take away the 2 55-degree angles, that is going to give me the measure of this angle right here. Okay, so that's going to give me this measure. Okay, so if I go to my calculator, if I do 180 minus 55 minus 55, that red angle is going to be 70 degrees. Okay, so now I finally have the measure of some angle inside of my triangle. Okay, so we actually have enough information at this point to begin working the problem now that we have one of those interior angles. Okay, look at what you have. Okay, when you're writing this down in terms of like, am I dealing with side angle? Am I dealing with side or side angle side? If you're trying to figure out what you're dealing with, okay, remember everything has to be contiguous. Okay, you need to start somewhere and then write the next thing you're given and then write the next thing you're given. Okay, so we just finished up on this 70-degree angle. So that is an angle. And then if I look, if you follow my cursor, I've got the angle, then I've got the side next to it, okay? And then I've got the side next to this, okay? So you end up with a wordy-dirty, and that's why if you go back to the cases, this is actually a case, but we don't call it this because of the wordy-dirty. So we're going to reverse it here because of the wordy-dirty, and we're going to start right here, okay? I've got this side, the side from X to Z, and then I've got the side next to it from X to Y, so that's another side, and then I've got the angle right next to it. Okay, so this is the case of side angle, which is the ambiguous case. Okay, now I'm going to tell you this. For these application problems, when you come across side angle in the ambiguous case, it will be the case of one triangle. Okay, you can do the work to check it, okay, but it won't be any of the tricky situations, but we will review that not in some kind of context. We'll just do a general problem to review the ambiguous case. So with these application problems that we work through, You can just rely on the fact, and you can double check it, that each one of these is going to be the case of just one triangle. Okay, so nothing tricky. Okay. All right, so since we have identified this as side-side angle, that means you need to use the law of you need to use the law of sines. Okay, remember, what do you need to remember? Sides and SAS, that's when you use law of cosines. Everything else is going to be law of sines. Okay, so we need to, you can go back and review on page 2. Okay, if we scroll up to law of sines, okay, here it is. Okay, but we need to figure out which version out of these 3 equations to use, and that relies on what we're looking for and what we're given. Okay, so let's go ahead here and do some additional labeling. Okay, this is going to be angle X right here. This is angle X. Okay, so straight across from it is going to be side X. Okay, and then you have angle Z right here. Straight across from it, you have side Z. And then right here in red, this is going to be the angle Y. So straight across from it is side Y. Okay, so that is the naming convention. Okay, so we are interested in finding side lowercase x, which is the same thing as YX, that line set, or sorry, YZ, that line segment. Okay, so we definitely want to involve side lowercase x, which means we're going to involve angle X. However, if I went the direction and I did sine of angle X over lowercase x, that is going to be a problem, even though we're solving for lowercase x, okay, because it involves 2 unknowns. We don't know angle X and we don't know the side X, okay? So we need to use given information just to get us started, okay? If you look at this, you can realize that we do know the measure of angle Y, and we also know the side Y, okay? So I am going to start by using this, okay, sine of angle Y over side Y, okay, is equal to, okay, then I also know something about Z, okay? I don't know angle Z, but I know side Z, okay? So if I set up this statement, that's going to leave me with one unknown, and it's going to allow me to solve for angle Z. Okay, and that's going to get me somewhere. Okay, we're after the distance from Y to Z. We may not be able to get there immediately. Okay, we're going to have to, it's a progression. Okay, so this is what we're going to start with. This is going to be our first step. Okay, so if I plug into this, what does this tell me? This tells me that the sine of 70 degrees over 400 is equal to the sine of angle Z. We don't know what angle Z measures, okay? But we know that side Z is also 400, okay? So this is a ratio that we can solve to get angle Z, okay? We have one fraction equal to another, so how do you solve something like that? Well, you cross multiply. Anytime you have one fraction equal to another, this times this has to be equal to this times this. Okay, so if we do that here, this is going to tell us that 400 times the sine of Z is equal to 400 times the sine of 70 degrees. Okay, so that's what we have so far. Okay, and now I'm going to solve for angle Z. Okay, on the right side, 400 times the sine of 70 degrees, that's just a number. And if you notice, the sine of Z is being it's being multiplied by 400. So what I'm going to do in the next statement, I'm just going to rewrite this. I am going to divide by the 400. Okay, and then you'll see that there's some cancellation here. These guys will cancel, these guys will cancel. This is going to tell me that the sine of Z is equal to the sine of 70. Okay, And so basically you don't really have to do any work here. We've gotten to a situation where sine of an angle is equal to the sine of 70. We can see clearly here that Z is going to be 70 degrees. All right, so I'm going to go and label that. Okay, so in my picture, I know that angle Z is 70 degrees. Okay, now I know two interior angles of the triangle, so I can figure out by subtracting from 180 what angle X measures. Okay, so for angle X, okay, I'm going to take 180 degrees and subtract the two 70-degree angles. Okay, so this is going to be 180 degrees minus 140 degrees, and so we get that angle Z is 40 degrees. Okay, so we can go ahead and say maybe this was my second step. Okay, I got another angle out of this, so I'm going to go ahead and label angle X as 40 degrees here. Okay, so now that we know all of the angles, it's going to be super easy to solve for side X. Okay, again, we need to be using the law of sines here. Okay, so in this last step, okay, I can make a ratio that involves X because I know angle X. Okay, so I'm going to say the sine of X over X is equal to what's going to go on the right. Well, it doesn't matter. You can put sine Y over Y, or you can put sine Z over Z because you know all the information about Y and you know all the information about Z. It doesn't matter. Just pick one. Okay, I'll use Y. Okay, so sine of Y over Y. Okay, let's plug into this. Okay, so we're going to get that the sine of 40 degrees over distance X is going to be equal to the sine of Y. This Y is 70 degrees. Side length Y is 400. Okay, so this is what we need to solve for. Okay, so again, we have one fraction equal to another, so we can cross multiply. This times this has to give me this times this. They have to be equal. Okay, so if we pop into this or we plug into this, we're going to get that X times the sine of 70 degrees is equal to 400 times the sine of 40 degrees. Okay, sine of 70 degrees is just a number, as is 400 times the sine of 40 degrees. Okay, we're solving for X, so we can just divide it off. Okay, so let me write this again for your notes. I'm going to divide both sides by the sine of 70. Okay, so we're going to get some cancellation on this side. Okay, so this will cancel with this. Okay, so to compute X, all we need to do is put this into a calculator. Okay, so I'm going to go to my calculator. I'm going to put in 400 times the sine of 40 degrees, and I need to divide that by the sine of 70 degrees. And there you go. Okay, this is going to be the length of side X. Okay, so we're going to make sure your calculator is in degrees when you're computing this, or you won't get the correct answer. Okay, just want to point that out. So let me go ahead and jot this down. 273 point, let's see here, what do we get? 273.6161147. Okay, so this is side length X. I need to round to the nearest mile. Okay, so we're going to go ahead and say this is approximately 274 miles. Okay, so that is the length of side X, okay, that we're looking for. Okay, so I can go ahead and label that in the picture. This is approximately 274 miles. Okay, so that's the first answer. Okay, we also, if you look in the blue, we need to know the bearing of Z from X. Okay, so you know, the bearing's going to be an angle. Okay, so what angle are they talking about? Okay, the bearing of Z from X. Okay, so let's look at this side XZ, so basically side lowercase y. Okay, when you look at this, okay, it's talking about this angle. Let me see, what color can I use? Let me get a different color here. Let's use orange. Okay, so it really stands out. It wants this angle. Okay, basically, what is the bearing of this side from X to Z. Okay, so that's what we have to figure out. Okay, you have to write it in bearing form. Okay, so it's actually really easy because if you look at this orange angle, it's made up of the 35-degree angle and the 40-degree angle. Okay, so all you have to do is add those two angles together, and that's going to be your bearing. It's 75 degrees. Okay, you don't have to give any directions here because if you look at the other two bearings, they have not been expressed in terms of directions. They were just given by angles. So this 75 degrees is understood to be, you're drawing, you're starting from due north and you're rotating 75 degrees clockwise. Okay. If you want to write the answer like the other two angles are given, you can go ahead and say it's 75 degrees and 0 minutes. Okay, so that would be your answer. Okay, so let me go ahead and kind of summarize what we did here. Okay, so we had to find two things from this problem and we had to use the law of sines. Okay, the distance YZ, we computed that to be approximately 274 miles. Okay, so that's the answer to this one. Okay, so let me put this in a box. Okay, so this is the answer of this. And then the bearing here from Z to X. Okay, so basically you're talking about the bearing of this line segment here from X to Z. Okay, that bearing is 75 degrees and 0 minutes. Okay, you can see from doing these problems, they can be quite complicated. You must draw them out to solve the problem.